All right, so here what we have is finding the absolute max and min. And again, when you're looking at this, you see these equal to signs, and those equal to signs, when you convert them into parentheses or bracket notation, this is equivalent to writing -4, 11 in a square bracket. So we do in fact have a closed interval here. Now, just for an FYI, if you had strictly less than, of course, that would be parentheses. So the fact that you have an equal to, that's telling you it's the same as a square bracket. So because we have that closed interval, we know that it's critical numbers, and then compare the y values. So to find my critical numbers, I'm going to take the first derivative, so bring down the 4x to the third minus the 50 times 2 gives us 100x, and then the plus 2 goes to 0. Now you'll notice here that it's not a linear expression that I'm setting equal to 0. My highest power is a cubic. So just like those quadratics where I had square, I need to factor first. And when I'm factoring, I am going to think about, and it's all driven off of that cubic power, the fact that it's not a power equal to 1, I need to factor. But when I factor, I'm going to think about what is the GCF. So here, the GCF would be a 4x, and that would leave us with x squared minus 25 is equal to 0. You can further factor the x squared minus 25 as a difference of two squares. So x and 5 and x and 5, and then one's negative and one's positive. Again, a difference of two squares. So now that we're setting that equal to 0 to find our critical numbers, we're going to set the 4x equal to 0, and then the x minus 5 equal to 0, and the x plus 5 equal to 0. So simply divide by 4 here, we get x equals 0. Add 5, we get x equals 5, and then subtract 5, we get x equals -5. Now, at face value, it looks like you have three critical numbers. However, on the interval -4 to 11, you will notice that the critical numbers that are actually on that interval are x is equal to 0, that would be inside the interval, and x is equal to 5, that would be inside of this interval -4 to 11. The x equals -5, that is outside of the interval -4, 11. Now, I don't want you to get into a habit of drawing a number line because I think it's going to really confuse you into the first derivative test potentially. So just as a quick FYI, the picture is you have -4 to 11. That's the interval of interest. And then this -5 number is totally outside of that interval. So that's the reason why we are not including -5 as a critical number. So that's a little tricky there, is that you did generate a critical number that was outside of the interval. And so that means that you have to eliminate it. You're not going to include it in your t-chart. The only numbers that you're going to include are the 0 and the 5. All right, so I create my little t-chart here. Again, when I create my t-chart, I'm plugging in to the original function, and I'm going to plug in my critical number that I have and my endpoints that I have. So my critical numbers were 0 and 5. The endpoints were -4 and 11. All right, now I want to see this process on your test, the first derivative, and then I also want to see you plugging in. Obviously, this gets a little cumbersome. I do want to tell you that it is totally fine with me, in my opinion, if you kind of work with your graphing calculator to expedite this plug-in step, because again, it is a little bit of plugging in, and you don't have to have a graphing calculator for this class. So if you don't have a graphing calculator, you would just take and maybe just plug in with parentheses all of those quantities to get the value. However, really quickly here, and I had this on 2 pages ago, what you can do on your graphing calculator is you can go and type in the function, the x to the fourth minus 50x squared plus 2. Then you can hit second table set, and you can set it to the independent variable being from auto. So you would use your little cursor down from auto over to ask. Once you do that, when you hit second table, so when I hit second table, you'll see a blank table. And that is where you could type in these numbers that I need to evaluate. So you could type in the 0, and that's going to give you 2. Then you could type in 5, hit enter, and that gives you negative 623. Then you could type in negative 4, hit enter, that gives you negative 542. Type in 11, that gives you 8,593. Whoa, that's a big number. Okay. All right. So that is one way of doing this. Again, if you just want to go to your calculator, type in parenthesis 11, you could do that too. It is totally fine. Okay. It really, really does not matter what you want to do there. All right. So then what we're going to do is we're going to compare these y values. And when you're comparing these y values, you're going to look at the biggest y value. That's going to be your absolute max. And then the smallest y value will be your absolute minimum. So my smallest y value is this negative 623. So we'll say that the absolute max is 8,593. That occurs at 11. And then the absolute min is negative 623 at 5.